Okay, in the lesson today then, you're going to be looking at some modelling with trig functions. So, Mr. Beagle has said that you have recently done the R addition formulae. So just a quick reminder of those. The formulae were if you had A sine theta plus or minus B cos theta, we could write that as R sine theta plus or minus alpha. And if you had A cos theta plus or minus B sine theta, you could write those as R cos theta minus plus alpha. So those are the R addition formulae, if you like. So what we're going to be doing is we're going to be using these formulae in kind of real life situations. That's why it's called modelling. So we're going to model this question with these R, cos or sine things. And I'll give you this example in a document so that you can print it out if you need it, or you can have it. So if we've got these formulae, what we're going to need to do then is to put this. So if we read the question, it says, a bicycle is travelling at constant speed. The height above the ground of the valve of the tyre, measured in metres at a time, can be modelled by this function. So if we're modelling it with this function, what I'm going to do is to try and rewrite this function into one of these R, sine, cos bits. So the 0.34 bit at the start, I can kind of ignore, can't I? So I'm just going to look at this second bit here. So if I look at that, it's something cos 14.5t minus something sine. So it's cos minus sine. So if you think about over here what that was in these formula, cos minus sine, that's going to give me this bottom one, isn't it? So it's going to be R cos the angle plus alpha. So the first thing I'm going to say is that bit there, the 0.252 cos 14.5t minus 0.144 sine 14.5t, I can write as R cos 14.5t plus alpha, using one of those formulae. And then I just need to work out what this is going to be, don't I? So if I remember what these look like, that's going to be R cos alpha cos 14.5t minus R sine alpha sine 14.5t. That's what I would get if I use the addition formulae, the cos A plus B. That's what I get. So comparing my coefficients, hopefully I can see that this R cos alpha has to be 0.252 by comparing that with that. And on the other side, I then know that this has to be equal to this. So R sine alpha equals 0.144. And then there are a few ways of thinking about this. It's entirely up to you. I sometimes think of this as cos alpha then equals 0.252 over R, and sine alpha equals 0.144 over R. So if I imagine a little right-angled triangle with alpha, cos is A over H and sine is O over H. So I get that. And then from there, it should be really easy to work out R and alpha, shouldn't it? So I can say, well, if I use Pythagoras to work out R squared is just 0.252 squared plus 0.144 squared. So R will be the square root of that. And that gives me an answer of 0.29. And the same, I could think of this as tan alpha equals 0.144 over 0.252 alpha equals tan to the minus 1, or arctan of that, and alpha equals 0.52 radians. So I've got those two values. So if I were then to rewrite, if we think about what this equation was at the top up here, this one, if I were to rewrite that, then I could say HT is equal to 0.34, and instead of the last bit I can put then that's plus 0.29, that's R, cos 14.5t plus 0.52. So that's my first step. I've rewritten the function as one of these R addition bits. So let's read the question now. So the maximum height above the valve, the maximum height of the valve above the ground in meters to two significant figures, and the first time this occurs in seconds. So what would the maximum height be? So you've got to really think here about what values I can have. So the maximum value of this, if you think about your equation, the maximum that this bit can be, that's the only bit that can change. The rest of it is kind of fixed, they're constants. The maximum of that is 1. So the biggest that could ever be is 1. Cos of something, the highest that could ever be is 1. So the maximum is when this bit, the cos 14.5t plus 0.52 equals 1. And the height at that time, so when that equals 1, ht will simply be 0.34 plus 0.29, which equals 0.63 meters. And when that's equal to 1, so if you think about your cos graph, when is the cos graph equal to 1? And it says it's maximum height and the first time it occurs. So after it starts, where's the first time that the maximum height occurs? So thinking about cosine graph, like that, isn't it? So this maximum height here, that's at 2 pi, 360 degrees or 2 pi. So it occurs when this angle, 14.5t plus 0.52 equals 2 pi. And if you solve that, you get t equals 0.40 seconds. So the maximum height is 0.63 meters, and it happens at 0.4 seconds. Okay, then, second part of the question said, let's look at B. The distance of the valve from the outer circumference of the tyre in meters to 1 sig fig. So, if you imagine your tyre, you've got kind of your tyre, and then you've got kind of your inner tyre, and then you're going to have this valve here, say. So, I want to know what this height is off the ground. So, that's going to be, if you imagine how this is going to go, this is going to go round in this circle, isn't it? So it's going to go kind of up and down kind of periodically. So this is going to be at the minimum height, isn't it? So that's at the minimum height. And the minimum this is going to be, remember your function was this one. So if the height function is 0.34 plus 0.29 times cos 14.5t plus 0.52. The minimum that this could ever take is minus 1. So all I want to know is, well, what is the minimum height? So the minimum height is going to be when that equals minus 1. So the minimum height is going to be 0.34 minus 0.29, which is 0.05 meters off the ground. Okay, part C then asks us, let's have a look. The time taken for the tyre to complete one full revolution in seconds to two significant figures. So the time it would take to go round once. So just remember again that your function for this is 0.34 plus 0.29 cos 14.5t plus 0.52. So, what they're basically saying is, how long does this take to do one complete revolution? So how long does it take to do one back up and down again, wherever it goes to? So what you need to think about is how long it would take to do one complete rotation if it was just cos. So we're looking at cosine here, aren't we? So we're looking at cosine. So the cosine graph would usually do that in a 2 pi window, wouldn't it? The plus 0.52, that just moves it to the left 0.52, but that doesn't matter. We're just moving it slightly. This 14.5 times the angle, that's going to squish it. It's going to squish it in on the x-axis, isn't it? And we're going to get that many of them in the same place. So it's going to be 14.5 of these rotations within the space that it used to take one. So the period, as we call it, or how long it takes to do one rotation, is just 2 pi divided by 14.5, because I'm going to squeeze 14.5 of them in the same space. So the time it takes to do one full revolution is 0.43. Okay, and let's look at part D then. So part D says, find the speed of the bicycle in meters per second to two significant figures. So what I need to know is I need to know how far the bike travels. So what I really need to know is the circumference of the tire. I need to know how far is the bike travelling in every one revolution. So every one time I go round, how far is that travelling? So if I take my tire, so let's just think about what we found out so far. So we discovered that if I have my tire, so let's imagine this is my tire, and we discovered that this distance here, so basically the width of the tire is 0.05 meters. And we discovered that when it was at its maximum, the valve was at its maximum, that was 0.63 off the ground. So this distance from here right down to the floor is 0.63. So the distance right up to the top of the tire, or the diameter of the full tire, is going to be 0.68 meters. If I know that's the diameter, the circumference is pi times d, so that's going to be pi times 0.68, so that's 2.136 meters. And then to work out the speed equals distance over time. So the speed is how far it travels. So in one full turn of the wheel, it's travelling 2.136. And I've divided that by the time it takes. So we have up here, it was 0.43. In fact, if we want to keep it more accurate, we could put 0.433. I think that's what it was. And then the speed is 4.9 meters per second.